Okay, so today we're going to talk about exponents. Before we get started, just remember at Learning with D is where you can get all the information you need, Facebook or IG, okay? So what is and how do we use exponents? To understand that, we have to first start by taking a look at what is an exponent. So generally, we might see something that looks like this, 4 to the second power. That is how this is read, okay? 4 to the second power, or 4 squared. So what are we talking about? We're talking about something raised to a power, okay? And so what we do is we call this the base. And we call this the index or the power or the exponent. So we say a base is raised to the x power, the second power, or to a power of 2, or it has an exponent of x. So in this case that we spoke about just now, the 4 and 2, the base is 4. If you were asked to break this apart, the base is 4. And the power, the exponent, if you will, is equal to 2. So what does this all mean? Okay, what does it mean? First of all, if I see a to the x power, what it means is I'm going to multiply a by itself, however number of times x is. So if I see a to the second power, or a squared, I'm going to multiply a by itself, and you're going to have 2 a's. If I see a to the third power, I'm going to have a multiplied by a multiplied by a. See, I have 3 a's. So if I have, as in the case that we started with, if I have 4 squared, I'm going to have 4 multiplied by 4. And this little dot in here just means multiply. Means multiply. But because we're not at a point where we're starting to use other letters as variables, x and y and z, we try to avoid using x where possible to represent times, okay? So 4 squared is equal to 4 times 4, which is equal to 16. So 4 squared is equal to 16. Let's take another example. Let's say I had 2 to the 4th power, okay? So I'm going to have 2 multiplied by 2, multiplied by 2, multiplied by 2. Do I go again? No, because I already have 4 2's. 1, 2, 3, 4. See? Only 4. So what I'm going to do now is I'm going to go ahead and multiply this up. And so I know 2 times 2 is 4. 2 times 2 is 4. So this comes down to 4 times 4 is 16. So however you want to do this, the answer is 16. Here's another way you could have done this, right? You could have said 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Either way, the answer is 16. 2 to the 4th power is equal to 16. Okay, and it doesn't matter if it's a fraction. It doesn't matter. Let's take a look at another example. Let's say I have 1/3, and this is raised to the 3rd power. So this is raised to the 3rd power. This is equal to 1/3 multiplied by 1/3 multiplied by 1/3 until I see 3 1/3. 1, 2, 3. Then I go back to my fraction multiplying. In multiplying, I take the numerator multiply it by itself, the denominator multiply it by itself. But in this case, 1 times 1 times 1 is 1. 3 times 3 is 9, times 3 is 27. So 1/3 cubed is equal to 1 over 27. All right. So what if I had something interesting like, let's say, 2 to the 0 power? Well, this is equal to 1. Because there's a specific rule when dealing with the laws of indices which says a to the 0 power is equal to 1. Meaning anything raised to the 0 power is equal to 1. If I had 1/3 raised to the 0 power, it's 1. If I had 100 raised to the 0 power, it's 1. If I had -6 raised to the 0 power, it's 1. This rule dictates that anything raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1. We haven't tried a negative number yet. Let's try a negative number, okay? Let's say I had -4. -4 squared. What this is -4 multiplied by -4. Now, I'm only going to do this once. Put a dot between brackets, because when we're using brackets, we don't have to put the dot. This is actually the same thing as saying -4, -4. As long as they're in brackets, this means multiplied by. So -4 times -4, and that is 16. But the concept here is that we look at the square and we take that number, whatever that number is that we're squaring, that is raised to the 2nd power, that has a power of 2. Means you're going to multiply that by itself that many times. So this is considered 2 times. If I had -2.5 raised to the 3rd power, all I would do is come here and I would say -2.5 multiplied by -2.5 multiplied by -2.5. Now, going back to your fractions, this isn't how we would do this, right? We would convert this to an improper fraction. This would be -5/2 multiplied by -5/2 multiplied by -5/2. Because that's what -2.5 is. All right. So that is what it means when we're talking about power. Now, there is a set of laws which govern computations with indices, and those are referred to as the laws of indices. So in your laws, you will see such things as, you will see that a to the 0 power is equal to 1. You will see, for example, that if you multiply 2 numbers that have powers, but they have the same base, then what we do is we do x plus y, add the bases. If we divide a to the x divided by a to the y, notice same base, a is the base, okay? What we're going to do is we're going to subtract these powers. And there are a couple more laws that we have in our books that we will cover in our next video if you're interested. However, for now, I hope that this video helped give you a perfect understanding of what power is and how we use it. Go ahead, subscribe to this channel, take a look at the next video, give it a thumbs up.